Okay, you guys, so we're going to review a little bit about absolute value equations. You did do this in Algebra 1, but we will review it as if we forgot. So if absolute value of x is 7, what are the possible values of x? So it could either be 7 or negative 7. If the absolute value of x equals negative 4, what are the values of x? So there's none, because negative x cannot be negative 4 away from the 0. It's distance, so distance can't be 0. So steps to solve. Isolate the absolute value expression. So we got to make sure it's all by itself. Create two cases, the inside equation to both positive and negative values. Solve both equations. Check for extraneous solutions. And what is an extraneous solution? Solutions that do not work in the original equation. Alright, so sometimes we just have to think back and check. So number 3, we're just going to start with the odds, I think. So for number 3, I have the absolute value of x minus 9, so it's already isolated, so let me create two cases. X minus 9 equals positive 5, and then x minus 9 equals negative 5. So that's how we create the two cases. I have to solve the same way, so I get x equals 14, x equals positive 4. So 4 and 14. For number 5, notice there's something attached to it, so let's move that over before we create our two cases. So I get 6 equals y minus 1 absolute value. So I'm going to create my two cases. Y minus 1 equals positive 6. Y minus 1 equals negative 6. Add 1. So y could equal 7. Add 1. Y could equal negative 5. So we can say y equals negative 5 or 7. Ooh, I like number 7. So the first thing I'm going to do is get rid of that 16 that's attached to the outside by dividing it by 16, and I get the absolute value of r minus 5 equals negative 2. So for this one, this is a no solution. You're never going to get an absolute value to equal a negative number, so we stop right there. Okay, so let's flip. For this to focus a little bit better. There we go, much better. Okay, so for this one we need to add 11 first. And now I get 6 equals the absolute value of 8 minus p. So that makes sense. We could separate this to 8 minus p equals positive 6. 8 minus p equals negative 6, and we can solve separately. So subtract 8. I get negative 2 equals negative p, so p must be positive 2. Minus 8. I get negative 14 equals negative p, so p must be positive 14. So p equals 2 and 14. Let's jump down to number 11. I'm going to subtract 9 before I do anything, right? So that's gone. I'm left with negative 4, absolute value c plus 10. Negative 15 minus 9 is negative 24. I still have something outside of my absolute value, so I'm going to divide by negative 4. So then I get absolute value of c plus 10 equals positive 6, which thank goodness for that. So let's separate this. C plus 10 equals 6. C plus 10 equals negative 6. Subtract 10. I get C equals negative 4. Subtract 10. C equals negative 16. C equals negative 4. Let me rewrite this. And negative 16. Okay, so then let's do number 13. So for number 13, I already have it isolated, so this is just different. So 3x minus 9, you keep everything the same on this side, but then on the other side we got to make everything opposite on this side, so it's like multiplying by negative 1. So it becomes 3x minus 9 equals negative x minus 1. So I always like to move my x's first. So I have 2x minus 9 equals 1. Add 9. I get 2x equals 10. So x must be 5. I'll do the same thing on this side. I like to keep my x's together, but this time, since it's a negative x, I'm going to add x. So I get 4x minus 9 equals negative 1. I'm going to add 9. Get 8 equals 4x, so x must equal 2. So far, so good. And let's see. We'll just stop there for now. I think that's a good enough video.